Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 5.1.1. We're going to start off with our M&Ms, which are just getting into our notes, the concept of equivalent ratios or equivalent fractions. I mean, we've been working with equivalent fractions for quite some time now, and how you use a giant one to find an equivalent fraction. Well, ratios are just a comparison of two quantities, and it can be shown as a fraction. It can be shown using words. It can be shown using the little colon kind of an idea. But the one that we're going to be using the most is when we put it into fraction form, and we can employ proportional reasoning. That's the word I'm looking for. Sorry, stumbled on that word a little bit. So you use a giant one to find equivalent ratio. So taking this situation, if you've got some sort of a recipe that calls for a ratio for every 4 raisins, you have 7 peanuts, and you wanted to increase, not double the size, not triple the size, but increase the size of that ratio by 20 times, you'd have to multiply the number of raisins times 20 and the number of peanuts times 20 to create this equivalent ratio. So this whole idea of equivalent ratios is the same as equivalent fractions. We've done this a lot. What do we have here? Find the missing values on the diagram. Assume that each line is evenly divided. Okay, so this is kind of what we were looking at yesterday when we were finding percents of different numbers. Looking across all the way across this, you can figure out what the total is just by doing a little bit of analysis. And here we know that 44% is equal to 144. So that piece of information is important because we can go ahead and say if 40%, which is 40 out of 100, is equivalent to 144 is going to be the part, well, what is the total going to be? What is the whole going to be? And so we could use proportional reasoning to figure that out. But being that we are using a number line to try and figure this out, we actually can use some other methods. For instance, we know that if from here to here is 144 units, and it's broken up into 1, 2, 3, 4 equal parts, then if we took 144 and divided it by 4, we would figure out what each one of these parts are, and then we'd be able to write it in all the way across. Okay, so let's do that first and see if this ends up matching that total. So it looks like 4 goes into 14 3 times. That's equal to 12. That's supposed to be a 2 there. And then you get 24. So that means that each one of these has to be 36. So each one of these intervals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, each one of these 10% intervals is equal to 36. So that means that the total is going to end up having to be 360, right? So this is 36, which 2 of them make 72, 4 of them makes 144, and this represents 50% of the data, right? 1, 2, 3, 4, 5 tenths is 50%, and this represents 40% of the data. So now let's go ahead and solve for x here, setting up this known information here with our total percent, it's 100%. So the total is going to correspond to the 100%, and the 144 is going to correspond to the 40%. And now let's solve for x. I don't know what I would multiply times 40 to give you 144, so I'm going to go ahead and do cross multiplication and say that 40 x's has to now be equal to 14,400, right? 144 times 100, add 2 zeros. There you go. So now if 40 times this number is 14,400, then 14,400 divided by 40 is going to give you what that number is. Okay. So let's go ahead and use the calculator. 14,400 divided by 40, 360 is the answer. That's what we thought it was supposed to be. Okay. So there are a number of different strategies that can be used. And using a diagram to analyze the situation is one way of doing it. Setting up the percent proportion is another way of solving these problems. And here's yet another one where you can use proportional reasoning. You can use some mental math logic, and you can use proportional reasoning. So let's read through the problem. It says a fish tank holds 80 gallons of water. Now it's important for you to be able to analyze that statement right there. It holds 80 gallons. That means that would be the total, the maximum amount that you can put in it. Because it doesn't hold more than 80. And if it holds 80, then that means, okay, well, it could also hold 40 or 44 or 22. So those would be the parts where 80 would always be the total maximum amount that would fit into the tank. Okay, so I'm going to go ahead and write that. The total here is going to be 80 gallons. And it says here, a fish tank holds 80 gallons of water. It's 55% full. So it's not 100%. 80 would be 100%, so it's 55%. So I'm going to write this in for the percent. It's going to be 55%. So if we take our percent proportion, which says the part over the total, right? The total always goes on the bottom, is equal to the percent out of 100. Okay, so just keep in mind, 100% is like maximum. That's the total. So the total with 100% go together in the denominators, and the part goes with the percent on the top. So when we take this problem and we set it up as a percent, or in the percent proportion, the total goes on the bottom, percent goes in the upper right, because that's where this is all percent in here out of 100. And so we're trying to find out what x is equal to. We'll come back to this in a second. Now, let's read through this problem. Create a drawing like Lewis's in problem 5.4 to represent the situation. All right, so I create a number line, and since we're talking about 80 gallons and 55%, you can break this up into 10 equal parts or 20 equal parts. I decided to just make it a little bit shorter and make it into 10 equal parts. So that means that 10% would be 8. Right? So 8, 16, 24, 32, 40. 40 plus 40 is 80. So each one of these sections is equal to 8. So if you're going to do 55%, then you can break that up into 50%, which would be 40. And if 50% is 40, then 10% has to be 1/5 of that, which would be 8. And then 5% would be half of 10%, which would be 4. So if you combine the 5%, right, half of one of these guys, half of an 8, plus another 5/8, right, that would be 50 plus 5 is 55%, would give you a total of 44 gallons. So that's our answer. So how many gallons are in the tank now? That would be 44 gallons. How much is needed to fill the tank? Well, whatever you add to 44 to give you 80, that's 36. That would be the other part. Okay, so let me just go back here. I'm going to get rid of all of this here. I'm going to get rid of all of that there. There we go. Okay, so I want to introduce you to this bit of logic right here. If you can find half of any number, right, 50% is equal to half. And if you can find 10% of any number, which is 1/10, right? You find 1/2 by dividing a number by 2. You find 1/10 by dividing it by 5. No, I'm sorry, by 10. Then you can get a lot of the information you need to solve a lot of these problems. So for instance, 80 gallons is the maximum capacity of this tank. If it was half full, it would have 40 gallons, right? If it was 1/10 of the way full, 1/10 of 80 is 80 divided by 10. That would be 8 gallons. Okay. So now let's start using some logic. We're going to take half of 10, and that's 5. So we'll take half of 8, and that would be 4. So this technically represents 1/20th of the tank, but still, it's just that basic logic. And so if you need to find 55%, then figure out what 50% and 5% are and add those together, and you will have your answer. Okay, now let's come back and show the proportional reasoning. The total was 80. We didn't know what the part was, but we know that part represented 55% of the total. So I'm going to cross multiply here. I'm going to take 100 times x is equal to 80 times 55. 80 times 55 is 4,400. So now when you divide this by 100, that's where you're going to get your value for x. And 4,400 divided by 100, I know what the answer is, but I'll just show it on the calculator anyway, is 44. So x equals 44, so that would be the number of gallons. That represents 55%. All right, using our giant 1 to create equivalent fractions. In some of these situations, they've given you the original fraction and the giant 1, and all you have to do is multiply straight across. In other situations, we're essentially using proportional reasoning. So take a look at this. If you have 9 over 15, and we're trying to figure out what our missing number is out of 60, you need to figure out what is your giant 1 that you're going to multiply times this fraction to give you this equivalent fraction. And in this case, it looks like 15 times 4 is equal to 60, so we will multiply 9 times 4 to give us this answer, which is 36. There's your 36 right there. So this is what we do when we use proportional reasoning, and we're able to find a giant 1. In some situations, I would recommend maybe doing cross multiplication, but you don't always have to do that. You can just look back and forth. What do you multiply times 20 to give you 110? 5.5. So multiply 7 times 5.5, and that'll give you your answer. And then same thing here. You can think of dividing a number. This one I would probably not use a giant 1 to solve this problem. I would, because I mean, you can. It's not a problem doing it. What do you multiply times 100 to give you 60? It's a decimal number, 0.6. So multiply 0.6 times that. I just would feel more comfortable doing cross multiplication. So you get 100 times x is equal to 44 times 60. 44 times 60 is 2,640. 2,640. So when you divide that by 100, you're going to get 26.4. So either method works fine. I always encourage students to look for the giant 1 first, though, because if you can do it in your head, you save yourself a lot of time. You don't have to worry about the proportional reasoning down here. All right, proportions web. Remember, the proportions web is just basically a model showing you that you can go back and forth between these representations of proportions. So here, the basic information. The situation says Clifford works 40 hours per week, and he earns $453.60. So that is the situation, which can be expressed as a unit rate. How many dollars per hour does he appear to be making? And so to figure that out, you would take $453.60 over 40 and try and figure out how much that would be over 1. So that turns into a division problem. So this number divided by 40 is equal to 11.34. I would show you on the calculator, but I'm hoping you'll trust me. So now that we've got our unit rate, now we can put that unit rate into an equation. We could stick it into a table of values, and remember 0, 0 will be a part of the situation because it's proportional. If you don't work any hours, you don't make any money. So if it's 1 hour is 334, then 2 hours would be 2268, and 3 hours would be 3 times 1134, and 4 hours would be 4 times 1134, and so on and so forth. So you got your unit rate from the situation, you've got your rule that is created, you've got a table that you can create, and you've also got a graph that passes through 0, 0, and passes through the unit rate of 1, 11, 34, which is an approximate location, by the way. I'm not certain that that's perfectly where it's supposed to go, but it's good enough for what we're doing here. All right, and practicing adding, subtracting, and multiplying fractions that are both positives and negatives in these situations. So when we add two fractions together, we always need a common denominator. And if you can't figure out within a few seconds of what your common denominator is, just do the coat of arms. Multiply 5 times 2, which is 10, and 5 times 3, which is 15. And now you are multiplying 2/3 times 5 over 5, and you've gotten yourself an equivalent fraction. The same thing with the 4/5, but multiply it times 3 over 3. So 3 times 4 is 12, and 3 times 5 is 15. And now when you add them together, you can, because you've got common denominators. So you keep your denominator and you add your numerators, and you can either write it as an improper fraction or a mixed number. Here, when you're multiplying, it's just multiply straight across. There's nothing, no tricks you need to do for multiplying fractions. So 4 times 2 is 8, 5 times 3 is 15. And in this situation, you get the same answer as A because it's really the same problem. If you do KFC, then you keep 4/5 as it is, you flip the minus sign to a plus sign, and you change the 2/3, or the negative 2/3, to a positive 2/3. And now you're essentially adding the two fractions together. You've just rearranged the order. So you're still going to have your 12 over 15 plus your 10 over 15 to give you 22 over 15. It's just going to be in a different order for adding. All right, so that concludes our homework for lesson 5.1.1. Let's move on to our next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed,